Hello everyone. Today let's solve the problem number 9.1, decode waste, right? So what the question states here, we are given a string S. Let's come to the example. You can clearly see here. We are given a string S consisting only of the digits. It consists only of the digits. So these digits, yeah, it consists only of the digits within the string. You can clearly see here. It consists of only digits. Each digit or pair of digits can be mapped to a letter from A to Z using like this. So I'll just come here, just give me a second here. So yeah, each digit or pair of digits can be mapped to a letter from A to Z. Here you can clearly see 1A. So this is within the string 1A, like that. So 2 B, right? So this one up to, so C will be 3, D will be 4, E will be 5, like that. It goes on, right? For 26 it will be basically Z or C, right? For 27 it will goes on, it will go on continuing actually. So for 27 it will be basically, what do you call, AA, right? So within the string it will be AA. This is fine. For 28 it will be this one, AB. It goes on continuous. I mean it goes on continuing like this itself. So this will be AB. This will go on basically. So this is what it happens, right? So this is what happens here. This is fine. So next step here is we must calculate how many different ways we can decode the string into valid sequence of letters. So how many ways are there, right? What are the different ways that we have, or that we can decode the string into valid sequence of letters? So that's what they have asked. So we have to return number of ways we can decode the string into the valid sequence of letters, right? So that's what we need to do here. So let me do one thing here. Let's come to the first example in this case. So here we have 12. So 12 can be decoded as AB. So A is 1, B is 2. So this can be decoded as this one. 1, 2 can be decoded as, quite obviously, AB. A is 1, B is 2, right? So this can be decoded as AB. Or we can directly consider L as well, which is 12 basically, right? A, B, C, D, E, F, G, H, you can just count. L will be 12 basically. We can directly consider L as well, right? So this one, so let me go with 12. So here it will be L in this case, right? So this is fine. These are the two ways we have. So this can be 12 can be decoded in two ways, right? So 12 can be decoded in two ways using AB as well as L. So we need to return the number of ways we can decode the string, right? So here in this case it will be 2. We have to return 2. Yeah, sorry. So let's come to the second example. We have 2 to 6. So this will be 2 is B, B, and 6 is F, right? So B, V, F we can, right? So 2 to 6. This is one way, right? So and we can consider here this one 2, 22 6 as well, right? But if we consider 22 6, 22 letter as V basically, and 6 is F, right? So this one can be decoded in this way as well, VF as well, right? So and the final one is we can decode in this way as well, 2 and 26. So 2 is nothing but B, and 26 is nothing but Z, right? So this can be decoded in this way as well, right? BZ or BZ here. So in these are the three ways that 2 to 6 can be decoded. So then we have to count the number of ways that the this one digit can be decoded, right? And this case we have to return the output 3. So we have three ways here, VF, BZ and BBF here on this, right? So these are the three ways. Let me delete this one, just give me a second here. Yeah, let's come to the third or the final part here, or the final example here. 0 6 we have, right? 0 6 we have. We don't have the this one, the letters, I mean the strings. Within the strings it always has to start with a digit, right? So 0 cannot be mapped to F because the leading 0, because of the leading 0. 6 is different from 0 6. If it starts from the leading 0, or if it starts from the 0, then we cannot map to any character. Just keep this in mind, right? So 06 cannot be mapped to F because because of the leading 0. 6 is different from 06, right? In this case, the string is not a valid encoding, so we have to return 0 in that case. So in this case, they have strictly mentioned, right? So when it starts from the leading 0, then we have to return 0. Or when it is not a valid string, in that case, we have to return 0, right? So they have given us wonderful examples just for the sake of understanding purpose, right? So I hope this is clear. I hope the question is completely clear. What we need to do is completely clear as well, right? Let's discuss the approach first, followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach first. The first step that we need to, the first thing that we need to note down here is we'll be going with the bottom-up dynamic programming, or we are going with the bottom-up approach, right? So we'll be going with the DP here. So I have considered the same first example that they have given in the question 1. So S equals 1 to, we have already discussed this one. We have two ways. One is AB, right? So AB because one stands for A and 2 stands for B here. In this case, or we can directly go for L as well, because L is 12th letter, right? Accordingly with the question, L is 12th letter, right? So either we can go with L or we can go with the AB. It means the numbers can be decoded in two ways here, AB or L, right? So we need to return the number of ways the numbers can be decoded, right? Here we have to return 2 in this case. This is fine. Let's move on with the step-by-step execution here. So the first step, what we'll do here, we will initialize DP of 0, nothing but the first 1 to 1 initially, 0th index, right? DP of 0 to 1 for the base case, empty string. For the empty string. So for the base case, what we will do, again, just remember this one, while writing code, it will be really helpful or handy. So we will initialize DP of 0 to 1 for the base case or for the empty string, right? So we will initialize DP of 1 to 1. Means now what we are doing, DP of 0 we are initializing to 1 and DP of 1 to 1 as well, because the first digit 1 is valid. So because they are saying first digit 1 is valid. This is fine, easy to understand. So let's move on with the second main step here. So current means S of 1 is 2, not 0. So we will be looping from I equals 2 to I equals 2. Means here S of 1 is 2. S of 1 is 2 means S of, just give me a second here. We have the digit, this one, 12, right? S of 0 is 1 and S of 1 is 2 we have. So this is what. So S of 1 is 2, not 0. Here in this case we have S of 2, S of 1 as 2, not 0. So DP of 2 plus DP of 1 equals nothing but DP of 2 itself, right? DP of 2 equals DP of 2 plus DP of 1. In this case, DP of 2 equals 1, right? So DP of 2 equals 1 itself. This is fine. We know this one, right? Simple. So previous equals S of 0. S of 0 we have here as 1, right? So 2 digit we have, nothing but 1, 2. Previous S of 0 is 1. 2 digit we have as 1, 2, which is between 10 and 26. Here what we'll do, DP of 2 equals DP of 2 plus DP of 0, nothing but DP of 2. In this case we have 2. In this case we'll get DP of 2 equals 2. This is fine, simple to understand. So the final output that we got here is 2, the second one, the final one, we will consider this one, right? So we'll consider this one, 2. So possible decodings equals, so possible decodings are here A, B, 1, 2 or L, 1, 2. So this one we have already discussed, right? Where multiple times while discussing the example, basically. So I've said this one multiple times. So the possible decodings are A, B, 1, 2, or we can directly consider L as well. That will lead to 1, 2 as well. These are the two decodings that can be done for the digits 1, 2, right? These are the two ways we have. So we have to return the ways, number of ways it can be decoded. The digits can be decoded basically here in this case 2. The output that we got here is 2, which is equivalent to the output that they have given for the example 1 and the question. So the output matches the, the approach works absolutely correct in this case, right? So the output that we got is completely equivalent to the output that they have given for the first example in the question. So the approach works absolutely correct in this case. Now, as we are completely familiar with the approach, let's discuss the this one edge cases step by step. So the first edge case is for the starts with 0 here. So whenever it starts with 0, we know that we have to return 0 itself. Why? We know that here 0, 06 is not valid, right? Because decoding cannot start with 0. So I have said this one during the question as well. They have clearly mentioned in the question. So S shouldn't start with 0. This is not valid, right? So 06 is not valid because decoding shouldn't start with 0. Shouldn't start with 0 basically, right? So this one, in that case, we will return 0 as output. This is fine. Single 0. So we have 0 here again. Whatever here, if it starts with 0, again we will return 0 itself when we have single 0. So this is for the edge case single 0. Let's move on with the third edge case here. So ends with 0. Ends with 0, this is fine. A ends with 0 means output is 1. How output is 1 here in this? So here in this case, what we can do, JA is valid, right? So J is 10. J is mapped to 10 here in this case, and we can go with A as well. But here in this case, 1 can be decoded to this one, A, but 0 cannot be decoded to anything here in this case, right? 0 cannot be decoded. 0 alone is invalid. So what we'll do, we'll not consider this one. So J equals 10 we will directly consider. So number of ways that 10 can be decoded is 1 in this case. This is fine. Let's move on with the fourth edge case here. 1 0 1 we have, right? So 1 0 1, 0 in the middle means 0, we have this 0 in the middle, right? So this one 10 we can go for J. From this one we have the idea that 10 we can go for the J. We cannot go with A and then we cannot consider anything for the 0, right? We have to directly go for the J for 10, and for the 1 we'll go with A here in this case, right? So this will be JA. So we have one valid, yeah, this can be decoded in one way, right? So 101 can be decoded to JA. So output we need to return in this case is 1. This is fine. Let's move on with the final edge case or the fifth edge case. 2 valid digits before 0. Before 0 we have 2 valid digits, right? So this, what we can do, we can consider 10 and 1 again, right? Or yeah, this can be considered 10 and 1. So here in this case, this can be decoded to JK, right? JK. J for the this one, JK for the for 11, basically JK for the 11 and 0. Just give me a second here, I got confused here. 0 must be part of 1 0, right? Here in this case 11 comma 0 will be 10, which is valid basically. So we have to go with JK itself, right? This is fine. We have to go with JK itself. Got confused. This is fine. Output we have to return in this case is 1. So these are the 5 edge cases that we need to consider here. The first edge case is for the starts with 0. The second edge case is for single 0. The third edge case is for ends with 0. The fourth edge case is for 0 in the middle, and the fifth edge case is for the 2 valid digits before 0. These are the 5 edge cases that we need to consider here. So now we are completely familiar with the edge cases as well as the approach. As we are completely familiar with edge cases as well as the approach, we are good to write the code. Let's start writing the. So first thing, what we'll do here, we'll get the length of the input string. So we'll be making use of the length of the string many times. So I'll just assign this one to the variable n here. In this case, we'll just go with n equals, we have the parameter s for the string. So I'll just go with s dot length. So this is Java, right? So this is fine. So the next step is, if string is empty or if string starts with 0, then it is said to be invalid. Means if string is empty or if the string starts with the 0, then it is invalid. 0, whenever it starts with 0, it is invalid. They have clearly mentioned in the question. We have discussed this one several times, multiple times, right? So just keep this in mind. If string is empty also, then also it is said to be invalid. Then we have to return 0 in that case. We have already discussed this one multiple times. So let's implement the same thing in the form of code. I'll just give here, in this case, n equals 0 or dot char at So the first, if it is empty, right? So if it is empty, or if s dot caret 0 means if the first letter, if the first character starts with 0, if the first digit is 0 basically, means within the strings if it is 0, then also we have to return 0, right? So this is fine. I hope this is clear, right? Simple to understand. So the next step here, we are going with the DP. I have said this one multiple times. We are going with the approach that we are going with here as DP, nothing but the bottom up approach, right? So DP of I is nothing but iterated value of the DP is nothing but number of ways that we can decode the first I characters. So here let me initialize the DP first. So here DP array. So int. So let me give here DP. So this one will be new int of n plus 1. This is fine. So after this, the base case is empty string has only one way to decode, right? Empty string has only one way to decode, and first, if the first character is valid and if it is not 0, so we have, in that case also we have one way to decode. These are the two cases: base case, first case, or the base case here as empty string has one way to decode. This we have to keep in mind. Again, if the first character is valid and if it is not 0, then we have one way to decode as well, right? So these two things we have to implement in the form of code. Once I'll just go with here dp of 0, let me assign this one to 1, dp of 1, let me assign this one to 1. I hope this is clear, easy to understand, right? Now we have to go with the iteration. We have to check for all the characters, right? So let me go with the iteration here. So I'll just go with here for I equals to I less than or equal to this one n. So let me increment the I here. Within this one we have to consider for the current character as well as the previous character. So I'll just, for the current character, I'll just give here char current equals, let me make use of caret here, caret. So for the current character I'll just go with the I minus 1. For the previous character I'll go with the I minus 2. I'll just copy the same thing and make the necessary changes here. So let me go with I minus 2 for this one. This is fine. So this is fine. I hope this is clear. So the next thing is we have to consider for the single digit valid decoding, right? So means if we have for the 12, we had two ways. Means we have to go with the single digit valid coding. Means for 12, for 1 we went with A, for 2 we went with B. That is single digit valid decoding. So also we can go with L as well, right? First let's go with the single digit valid decoding. Means here in this case I'll just go with the simple if condition, if current not equal to 0. So then what I need to do? So dp of I equals dp of I plus dp of I minus 1. This is fine. The next thing here is we have to combine the previous and current. Means for 12 we went with A as well as B, or we can directly go with L. There are two ways, right? So if we are going with A and B, we have to combine both previous and current, right? So I'll just go with here int 2 digit. So we have to combine for 12 A and B, we have to combine them, right? So here I'll just go with previous minus 0 within the string into 10 plus current, not minus, basically this is hyphen. So I shouldn't be saying this one as minus. This is hyphen 0. This is fine. We are just combining the previous and current. So then if it is valid 2-digit decoding, then we have to return it, right? So for the valid 2-digit decoding, I can just mention in this way: if 2-digit greater than or equal to 10, and same thing, I'll just copy the same thing here, 2-digit here less than or equal to 26, then what should I do? Then we have to return it. So I can just give here dp of I equals dp of I minus 1. We know this one, right? Finally, what we need to do here, we have to return the total ways to decode the full string. In this case, it is dp of n, right? So n ways. Total ways, we have to return the total ways to decode full string. Final answer. So I'll just go with return dp of n in this case. So this is it for the code. Simple to understand, right? We went step by step. So we discussed this one step by step. Just give me a second. Here, let me move this flower bracket. So this is fine. So let me hit the run button. I hope this works. Let's see. So we have error here, 2-digit double ampersand, and I have not written anything here. Line number 20. So yeah, what did I do here? Why have written this one 2 times? So let me remove this one. So let me hit the run button again. Less than, oh, this one I got confused here, I think. So this one again 2-digit. I copied this one and paste this one correctly, I think. So this is fine. Again 2-digit, less than or equal to 26 it has to be. Greater than or equal to 10, less than or equal to 26. So now we have error again. So I have not mentioned the int here. Where? Line number 11. Just give me a second here. So let me hit the run button. Let's see. Variable current is already defined in method num decoding of string. So this one, line number 13. So oh yeah, this one has to be previous, not the current. We are considering current and previous. So I type current again. This is fine. Let me hit the run button. So we are considering current character as well as the previous character right here. So still we are getting wrong output. What output we are getting here? Expected 3, but we are getting 4. So 1 we are getting. So for the first test case we are getting, for test case it is correct. For the third test case 0 0, this is fine as well. For the second test case we are getting 2 to 6. For the 2 to 6 we are getting 3 instead of 4 instead of 3. So let's check what. So what mistake I have done here is we have already done the single digit valid decoding here, and the line number, this one I'm speaking of, 16 15 16 if condition I have written right here. This is for the single digit valid decoding, whatever if condition I have written here, current not equal to 0. This is single digit valid decoding. Again we are going with the single digit valid encoding here as well. In the line number 21 we have to go with the valid 2-digit decoding right here. So we have already done the single digit valid decoding here. We have to go with this one, valid 2-digit encoding here. This has to be dp of I equals dp of I plus dp of I minus 2 basically, right? So we are going with the valid 2-digit decoding here. So I have changed this one. Let me hit the run button. Let's see whether this works or not. So yeah, now we can clearly see this, all the sample test cases are getting passed, right? So let me hit the submit button. I hope this works for all the test cases. Let's see. Yeah, you can clearly see here all the test cases are getting passed. Means the code works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is bottom-up dynamic programming or bottom-up DP here, right? So the approach that we went with here is bottom-up DP. We know this one. Or we can just call this one as we went with the dynamic programming. So overall time complexity would be here on this case, it would be big of n. Why it is big of n? Because we are iterating through the string exactly once, or we are iterating through the string exactly once or only once. Here you can clearly see line number 11 I'm speaking of, right? We are iterating through the string exactly once, doing constant time operations at each step. So overall time complexity would be quite obviously big of n. So what would be the space complexity here? The space complexity would be big of n as well. Why it is big of n here in this case? So we are making use of the DP array here. Let me come here. Yeah, here the line number 7 I'm speaking of. We are making use of the DP array, which is of the size n plus 1 here, n plus 1, which is of the size n plus 1 to store the decoding base, right? We have to store the decoding base, means result somewhere. So we are making use of the DP array of size n plus 1. So overall space complexity would be big of n as well, right? So overall time complexity and the space complexity for the code that we have written is big of n. I hope the complexities are clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.